Okay, let's begin Niyamadansa. Let's begin binomial theorem for positive integral index. Over here, if n is a positive integer, then a plus x to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 plus nc2 a to the power n minus 2 x to the power 2 plus so on. We are getting the last term is how much here? Ncn x to the power 0. Just a minute. Ncn a to the power 0, or a is not coming over here, and x to the power n. This expansion is known as binomial theorem or binomial expansion for positive integral index. Okay, so a plus x means how many terms? Two terms, a and x. This expansion goes like this one: nc0 a to the power n. Second term, nc1 a to the power n minus 1. A to the power n minus 1 means the power of n is decreases by 1 and x to the power 1. Second term is nc2 a to the power n minus 2 x to the power 2, and so on it carries. The last term will be ncn x to the power n and a to the power 0. Clearly, just and something like this one, what are positive integers. So I think all of you know the positive integers. What are positive integers? I think all of you know this one. But let us know positive integer means 1, 2, 3, 4, and so on. So positive integer means it does not include 0, it does not include fractional number like this one, 1 by 2, 1 by 3, 1 by 4, or it does not include decimals. So these are positive integers. And let us do one thing more over here. So NC0 means combination. This also can be written as CN0 like this one. NC2, this can be written as CN2 and so on. Okay, so this one is binomial expansion. Over here, NCR. NCR means just a minute, positive integer we have done over here. So now we are going to deal what the meaning of NCR. I think all of you know what the meaning of NCR. So NCR is combination formula. This is how much here? N factorial by R factorial into N minus R factorial. 0 is less than R is less than N. So this is the formula for LCR. So this is simple binomial expansion for positive integer n. Properties of binomial expansion. Okay. So first property, let us check over here. We are dealing over here. Just look in this expansion what we are dealing. So the terms are nc0 a to the power n. Over here the first term is a. The first term is a. Second is x. Second is x. So first term, power of n is how much here? A is how much here? N. No, sir. Of binomial expansion. Over here, just look. This is in the expansion. We are just over here a plus x to the power n. The first term is how much here? nc0 a to the power n, and this is x to the power 0. Second term over here we have dealt nc1 a to the power n minus 1 x to the power 1. Third term we have written nc2 a to the power n minus 2 x to the power 2. And likewise, what we are observing over here, the first term, this is the first term a, this is second term. The power of a is n. What is the index over here? N. Second term, the power of a is decreases by 1. Then after the third term, the power of n is decreases by 2. Like this one, all the preceding terms means all the succeeding terms, the power of n means first term is decreases by 1 or unity. Go for the second term, power is 0, power is how much here? 1, power is 2, and so on. If we write the next one term, this is how much here? nc3 a to the power n minus 2, then this one became n minus 3. This is 2, then this one became how much here? 3. So on, if we write the next term, nc, this is 3, then 4, a to the power n minus 3, then n minus 4, x to the power 3, then x to the power 4, and so on. It means what we observe, power of first term decreases by unity and power of second term increases by unity. So this one is the first property. So what we can write over here in expansion, power of first term, that is over here is a, power of first term, that is over here in this expansion is how much here? A, decreases by unity and power of x, that is second term, increases by unity means 1. So this is the first property. Okay, let us do the second property. Okay, so just go for second property. What is given? This one is a plus x, we have written in the beginning over here. So just go for this one only. This is how much here? Total index is how much here? N. The first term, the index is how much here? N itself. Second term, these are the two indices. A to the index is n minus n and 1. So n minus 1 plus 1 became how much here? N itself. N minus 2 plus x to the power 2. The sum is how much here? Again how much? N. Like this one, if we are writing over here, the next term is, if we are writing next term, nc3 a to the power n minus 3 and x to the power 3 and so on. It means again the sum of the power, this is n minus 3 plus 3, again becomes how much here? N. It means what is second property? If the index is n, sum of the powers of both the terms, like this one x and n, that one comes up to n1. So one example we can take over here. If we take example, so a plus x to the power 3, the first term the power is 3, second term the power is how much here? 3 a to the power 2 x to the power 1, again the sum is 3. Next term is 3 a to the power 1 x to the power 3. So second term the power is 3. So simply what we can get, sum of indices of both term is equal to the index of the expansion. Index of the expansion. So in this expansion what we can get, sum of power of first, sum of power of a and x in each term is in a. So this one is the second term property. I think up to this is clear to all of you. ठीक है? Property 3. So this is property 3. What we are dealing over here? Number of terms in any expansion is one more than the index. Like this one, if you take example a plus x to the power 4, then number of terms equal to 4 plus 1. If this is a plus x to the power 8, so number of terms is equal to 8 plus 1 means 9. So in each of the expression, number of terms is one more than the whole index. Means index is n, then the number of term is n plus 1. Index is 4, then number of term is 5. Index is 8, then number of term is 9. So this is one is the third property. Now let's show for the next one property. So just look over here. Over here, this one is the term 1 or T1. This is T2. Just observe this one. This is over here is T3. This is over here is T4. Okay. So look at over here. This is T1. So what we are writing? NC 0. Over here is how much here? 0 is coming. This is second term. Second term we are writing over NC1. The power is also n minus 1 x to the power 1. This is third term. This is 3. Then this is how much here? 2 and n minus 2 x to the power 2. This is 3. This is fourth term. So n minus 3 and x to the power 3. So this one simply can be T3 can be written. This is how much T3 plus 1. This can be written. T3 can be written as how much T2 plus 1. So over here this is 2. This is how much here 3. This index is 3. Over here T2. T2 means how much here we can write T1 plus 1. Okay. So similarly, if we expand, we are getting a term over here. This is how much here NCR a to the power n minus r x to the power r. So which term will be this one? Just imagine. So this is T4 means this is 3 plus 1. T3 means 2 plus 1. T2 means 1 plus 1. So NCR, it means this term will be how much here? TR plus 1. TR plus 1. Clear? So this one is how much here? TR plus 1. So this is one is known as the general term of a binomial expansion. So fourth one, property 4. So the general term in expansion a plus x to the power n is tr plus 1 is ncr a to the power n minus r and x to the power r. So this one is known as the general term or r plus 1th term. So general term in the expansion is how much said t r plus 1 ncr a to the power n minus r x to the power r. So this is quite important for finding all the values, all the expansions we are using this one when we have to find the fifth term, find the 50th term, another like this one, find the term independent of x, another. So this is quite important. We have to remember the r plus 1th term is how much here? ncr a to the power n minus r x to the power r. So let us begin. This is third one. So now we are going to start the fifth one. It's in the play.